So we are starting our functions and systems unit. So we're going to begin with just talking about what is a function exactly. You started this discussion back in Algebra 1, so we're just going to be taking this discussion and going a little bit further with it, as you can see down here in our third section. So relations, we're going to start with a relation because a relation really is the beginning point. So a relation is anything that can be graphed. And there is so many different kinds of things that can be graphed beyond what we normally do in just math class. You can graph spirals and you can graph just squiggles and lines, a whole bunch of different things, a collection of just some points. So a relation is anything that can be drawn on a graph. It can also just be listed as a set of points is another thing. So pretty much everything is a relation. So then we get into the functions. The functions are a big part of our curriculum. And functions are just more specific relations. So we just take our relations and we are just getting a little bit more specific with it, and we're looking at certain types of relations. So they're still relations, it's just they fit into a little subcategory, making them functions instead. So let's take a look at it. There's several different ways to be able to recognize our relations and our functions. So here we have a set of points. This is up here. So if we take a look at these, the way we can tell that this is a relation is you look at your x values, also known as your domain. If I were to write it out, D standing for domain, my little squiggly brace, my domain here would be 2, 4, and 5. Repeated values do not get written that many times. You just write it once. So this is a relation though, because that domain value of 2 is repeated. Domain value of 2 is repeated. We don't want that. The fact that that domain value of 2 is repeated means that that value has 2 separate range values, which are our y's, and we can't have that. That's why it's simply a relation, because that domain value of 2 has 2 range values that go with it. Which, just practicing it, our range values here would be -3, -1, 2, and 3. When we list them out in this way, this is called roster form. Roster form is just simply a list that goes from the least to the greatest. It always goes least to greatest. That's the way our roster form works. Okay, so this one is a relation. Our domain value of 2 has 2 different y values or range values that it goes to. So that's why it's a relation. Taking a look at our table here. If we're taking a look, again, our domain would be our x's. Our range would be your k of x. That's our function notation for our range. Again, we have that domain value of 1 here that's repeated. So domain value of 1 has 2 range values. So that is why it's a relation, because our domain value is 1, has 2 different range values. So it can't be the more specific function. It's going to stay as a relation for that. Our next way we can take a look at it is by looking at the graph. So for graphs, we use our vertical line test. We pass the vertical line test if we draw a vertical line on our graph and it only hits it once. If I draw my vertical line here, it hits it twice. So this fails the vertical line test. We tend to shorten vertical line test to just VLT. So this fails the vertical line test. So what's happening here is this domain value of -2 has two range values yet again. This is how it's graphically shown. So domain value of -2 has two range values, which is why this is a relation. The domain value has more than one range value associated with it. And then our last one is the mapping diagram. The mapping diagrams I find are fun. So this is a relation because the domain value of 4 has two arrows pointing to two different range values. So domain value of 4 has two range values. So that's what makes things stay as relations. If your domains have more than one range values that they connect to, that makes them relations. So then our functions, looking down at our next row here, our functions, each domain has only one range value that it connects to. So taking a look here at my set of points, my domain values are all different. I have domain of 2, 3, 4, and 5. And then my range values, -1, -3 should go first, -1 and 2. I have a range value that repeats, but that doesn't matter with functions. It's okay if that range value repeats in functions. So this is a function. Each domain value has one range value. That is why it's a function. Each domain value has one range value. So if we take a look at our table, again, here's our domain, here's our range. If I look at my domain values, they each have just one range value. It's not repeated. So this is a function. Each domain value has one range value. So looking at our graph, again, I'm going to do my vertical line test. And it really doesn't matter where I draw my vertical line. It's still going to hit it once. I didn't draw my vertical line more than one time up here in my circle because I already found an instance where it failed. So I didn't need to keep trying to see if I could find one. I didn't find any instances here where this failed. So this is a function. It passes the vertical line test. And so because it passes the vertical line test, that vertical line test is telling us each domain value only has one range value connected to it. So that's why it passes. There's not multiple ranges. And then our last one, our mapping. First circle is our domain. Second circle is always our range. So this is a function. Because each domain value has only one range value. As you can see, because each domain value only has one arrow coming from it in the mapping diagram. So moving on to more specific more specific functions. So we have what's known as the one-to-one function, and we have what's called onto. Now functions can be one-to-one, or they can be onto, or they can be both, or they can be neither. Okay? So what a one-to-one function means is that range and domain, so domain and your ranges, do not repeat. So they pass both the vertical line test, because that vertical line test first tells us that it is a function, but it also passes a horizontal line test because a one-to-one function, no values are repeated. No values repeat. So no values in the domain and no values in the range repeat. So this is a one-to-one. First, it passes the vertical line test. No matter where I draw that vertical line, it's going to hit the graph once. And same thing with our horizontals. Anywhere we draw a horizontal line, it's only going to hit the graph once. So this graph here is an example of a one-to-one function. So if we had a table, you would look at both domain and range, see if any of those values repeat. So like, for example, this table right here, this is a one-to-one function because our domain does not repeat, our range does not repeat. However, my set of points here is not one-to-one because this range value of 2 is repeated. So that's just a function. It's not a one-to-one function. All right. Next one, onto. An onto function means that every range value is used. Every range value is used. So for example, my mapping diagram that I have there, this range value of 4 right here is not being used. So this is actually not onto. This is an example of not onto. However, my graph over here that I used for one-to-one, this would also be onto because it uses every range. This is telling you it's going to keep going up forever. This is going to keep going down forever. It will use every range value possible. But for example, my absolute value graph up here, this is not onto because these range values below your vertex there are never going to be used. They're possible, you could use them, but this graph doesn't. So this graph is not going to be an onto graph. So in order for functions to be one-to-one or onto, they need to first be functions. So if they're not even functions, that you're not even going to check then to see if it's one-to-one or onto. So again, that one-to-one passes both vertical and horizontal line tests. No values are repeated. Onto means every single range value is used. Then our last thing over here, evaluating functions. So I have these two functions, f of x and j of x. So evaluating functions just means you plug those values in for your other function. So for example, this one's a little bit more complicated. We need to figure out j of 5, and then we'll subtract j of 3 from it, and we're going to divide it by j of 2. I'm using this function here for the entire thing. I'm going to plug a 5 in, then I'm going to plug a 3 in, and then I'm going to plug a 2 in. So plugging in the 5, that means it's going to be 2 times 5 minus 3. That's my j of 5. And then it's going to be minus j of 3 would be 2 times 3 minus 3 over 3 plus 1. I just realized I forgot my over 5 plus 1 here. And then my j of 2 would be 2 times 2 minus 3 over 2 plus 1. There's my j of 2. This is my j of 3. So I'm plugging in a 5, plugging in a 3, and plugging in a 2. I'll zoom in a little bit more so you can see that better. So I'm going to do a little bit of mental math here. 2 times 5 is 10, minus 3 gives me a 7 over 6. Minus 6 minus 3 is 3 over 4. And then over 4 minus 3 is 1 over 3. So 7/6 minus 3/4, all over 1/3. I'm going to use my calculator to help me with that part. So alpha, and then the x gives me that little fraction in there. So I'm going to do that a second time because I got my fraction 7/6, which is in the numerator here, minus alpha x, 3/4 over 1/3. So as you can see, I have it typed in my calculator exactly how I have it written on my paper here. 5/4 is my final answer. Definitely can use that calculator to help you with those fractions. Again, I hit alpha and then the x button right next to it, and it creates that fraction there. All right, next one, f of 3a. So that means wherever I see an x, I'm going to plug in a 3a. So that becomes 3 times 3a squared plus 3a. So 3a squared becomes 9a squared. And then times that 3 gives me 27a squared plus 3a. So whatever they tell you to plug in, which is in the parentheses, that's what you plug in for your x. All right, our last one here, j of 1 plus f of negative 3, and then squared. All right, so j of 1, 2 times 1 is 2, minus 3 is negative 1, over 1 plus 1 is 2, plus f of negative 3. So that's going to be 9 times 3 is 27, plus a negative 3, so that's going to be 24 squared. So really, and I'm going to use my calculator to help me here. I'm going to clear that out. So parentheses, alpha x, negative 1/2 plus 24 squared. $22.09. All right.